Hi, in this tutorial I'm going to discuss data input in Fruits. But since Fruits is a highly flexible model, this means that the user has the possibility of including or excluding the different model parameters so that a specific model instance may be designed to suit a specific mixing problem. But this flexibility also implies that there could be small differences in the way the user inputs data among the different model instances. So actually this is the first tutorial of a series of 4 in which I will illustrate data input in Fruits through the use of 4 different examples. And as a first example, we have this one in which we have one target and we want to estimate what was the contribution from 1, 2, 3 different sources. In this target, we have 3 different proxies, the isotopic ratios for carbon, nitrogen, and sulfur. Now, of course, the user could have more or less proxies. They are not limited to isotopic ratios. They could be other quantitative signals, for example, elemental signals. Now, Fruits separates the notion of proxies in the target from that of source, from that of fractions in the source. Okay, this can be very powerful. This can be used in other model instances, and it can be explored in a very effective way to address specific mixing problems. But in this case, our 3 fractions correspond. There's a one-to-one correspondence towards the proxies in the target. So we also have isotopic ratios for carbon, nitrogen, and sulfur. Okay. So let's then define this model in Fruits, and I here have opened a window of Fruits 2.0, and we start off by defining the model options. Now we assume that there is no isotopic offset, no isotopic fractionation between source and target, so this is an offset independent model. We are not interested in the concentrations of the fractions in the sources. And also, different fractions cannot contribute to a target proxy. Since I told you there's a one-to-one correspondence. If this was not the case, then it would be a weighted model, but this is a non-weighted model. Okay? And we leave the remaining options as they are. Okay? Okay, number of targets. We have 1 target. We have 3 sources. We have 3 fractions, those are the 3 isotopic signals in the sources, and we have 3 proxies, those are the 3 isotopic signals in the target. Then we press proxies, and here we enter the name for the proxies. So for example, proxy 13C, proxy 15N, proxy 34S. Okay? Fruits has some limitations in terms of the characters that you can use. No special characters are allowed and no spaces. So for instance, if I was to add a space here and then try to apply, it doesn't allow me because it cannot contain any spaces. So I'm going to remove that. And of course, the names for the proxies cannot be duplicated. And actually, Fruits in this respect also does not allow any duplication among the different names for the different parameters. Okay, so here I press apply, target data. This is my target data, of course, the isotopic values for the different proxies and the associated uncertainties, and also the ID for the target. And I have this data prepared in this data sheet here. So I'm selecting it, I'm doing a Control C, and then I press paste data. Notice that the decimal separator is a dot. This is the only decimal separator which Fruits accepts. So, for example, commas cannot be employed. Okay. Then I press apply. and then the next button is sources, and here one writes the name for the sources. So let's say source 1, whoops, sorry, source 2, source 3, apply. Then we have source fractions. Those are the names for the fractions. So for our 3 different isotopic ratios, let's give them names. So let's call this fraction 13C, fraction 15N, then fraction 34S. Okay, apply. Offsets and weights. We define this as an offset independent model, so no isotopic offset between source and target. And so what Fruits does in this case is set these offset values to 0, and the associated uncertainties are blank, and these values one cannot edit them. Now, so in this column we have our 3 different proxies, and here we have our 3 different fractions. And so we have to inform Fruits what is the relationship between the proxies and the fractions. And our proxy 13C, well, its signal is determined by the fraction 13C. And so to inform Fruits of this, one clicks in the cell where the column and the line intersect. So I'm doing that, and you see this value is set to 100, and these values here are set to 0. This means that the proxy 13C receives no input from the fraction 15n or from the fraction 34s. I could redefine this by clicking here, see? But this of course would be incorrect, so I'm clicking here again. Now the proxy 15n, well, its signal is defined by the fraction 15n, so I click here. And finally the proxy 34s is defined by the fraction 34s, so I click here. Okay. Now you cannot edit the uncertainties because we are assuming that this is a non-weighted model, so these are fully determined, the proxies are fully determined by these fractions, and there is no uncertainty in that. Okay. Then I press apply, and then the next section are the source values. Now we have 3 different sources. Okay, source 1, source 2, source 3, and for each source we have 3 different fractions. Fraction 1, fraction 13C, sorry, fraction 15n, and 34s, and then this is repeated for the other 2 sources. Okay. Now, remember that we established that the proxy 13C in the target, well, its signal is only determined by the fraction 13C in the source. And that's why only these 2 cells are blank and these ones are black, and it's not possible to edit them. Okay? In a similar way, our proxy 15n, well, that's only determined by our fraction 15n. And that's why only these 2 cells, it's only possible to edit these 2 cells. And finally, the same thing for 34s. The sulfur signal in the target, well, that's defined by the fraction signal for sulfur. Okay, and this applies to the other sources. So 13C is defined by the 13C in source 1, by the 13C in source 2, and by the 13C in source 3, and so forth. Okay. Now I have the data here. Okay, but it's not in the right format, this data. So this data would have to be distributed in a similar way as these blank cells in Fruits. So if I try to copy, Control C, and paste data here, you will notice that only these cells are filled in, and these are the wrong values. They didn't match the right distribution. So we could do this in 2 different ways. I could have a data sheet in which the data is distributed in the correct way, so that I could just copy paste it, or we can put in the data manually, and I'm going to do it manually. Okay. So this value here is, the first one is okay, the second one is minus 20. And the uncertainty, well, if it's a single cell, you can do a Control C and a Control V to copy paste, and I'm doing that, Control C, Control V, and I'm saving some time here. These are all the same, and this one is 0.3. So Control C, Control V, and now I'm plugging in the rest of the values, minus 5, and this is 15, and this is 10, and this is 3, and this is minus 10, sorry, minus 10, and this is minus 2, and this is 7, okay? And then I press apply. Finally, concentrations. Now we define this as a concentration independent model, so fruits sets all of these values to 100, and it's not possible to edit these values, okay? And so we press apply, and we have entered all data. I'm not introducing any prior info, so then we press estimate. And we just have to wait a few seconds so that the estimates are generated. Okay. And so what we have here are the box plots on the contribution from each source towards the target. Okay. The color-coded probability distributions. So let's put this as a smooth area. Okay. And the results report. So how many updates and how long it took. All of your input data is here, and the estimates are here. Now in this particular model instance, you can ignore these estimates here. You may focus only on these ones here, and I'm going to copy, paste them into this Excel sheet. So you have 60% estimated contribution. So this is expressed between 0 and 1, so 0.6, that's 60%. 60% contribution from source 1, 30% from source 2, and 10% from source 3. And I have actually here the correct values. So this is a good prediction from fruits, and here you have the standard deviation. So 6%, 10%, and 3%. Okay. Now, notice, for instance, there is some overlap between source 1 and source 2. Okay. And so we could try to improve the estimates, or to separate better the estimates by applying prior info. So for that I click here on prior info, and this list box here, so this refers to the contribution from the sources. So I can inform fruits that the contribution from source 1, okay, was larger than source 2. To add source to that, to add these source 1 and source 2 there, you have to double click over the listed items in this list box. Okay, so this is my expression: source 1 bigger than source 2. This means the contribution from source 1 was larger than that from source 2, and then I press add. Now it's listed as one of the priors, and finally we have to apply. Okay, and it saved that prior. So here it is: source 1 larger than source 2. The contribution from source 1 larger than source 2. And then we press estimate, and again we give it a few seconds to generate new estimates. Okay, so the model now achieved a better separation between these two sources. Okay, and now we still have 60, 30, 10, but the uncertainties now are smaller than before. We can add another prior. So notice that there's also some overlap between source 2 and source 3. So we can go to prior info. We have this prior already saved. We could remove it. Okay. but I don't want to remove it. I want to keep that prior, so I'll add it again. And what we will do now is add another prior, informing the model that the contribution from source 2 is bigger than that from source 3. And we do this by double-clicking on source 2, bigger than, and then double-clicking on source 3, and then add. And now we have two priors. Contribution from source 1 larger than source 2, and contribution from source 2 larger than that from source 3. Okay? And then we press apply, and then we press estimate, and again we give it a few seconds. So let's anxiously wait for the estimates. Okay, and here they are. Okay, and now we have 59, 31, and 10, and the uncertainties now are even smaller, as you can see. Okay, and that's it.